So the midterm's on March 14th. It covers chapters 1 through 3. Also covers the homework, right? Anything in the homework up till now, right? I'm not going to spring new stuff on you that I expect to be on the exam. Anything assigned by, last Tuesday, or this Tuesday, which is March 5. And then our notes. So the stuff from our online tests, our online quizzes, going to feature prominently in there. Also, just some general Python programming stuff that we've covered. I'm not going to try to throw too much that's not in the textbook at you. It's open text, open PowerPoint, open notes. I don't care if you print out every one of our notes, paste them all into a Word document, right? I'm going to make a folder so that you can upload any notes that you want to put in there. Let's go ahead and do that. On the other hand, if you're spending too much time looking up things, then it's going to be harder for you to get it done. Same thing for using Python. Same thing for cranking up Python. Answering a simple question with Python, loading up idle is okay, but if you're typing in entire programs, right? If I give you like 5-6 lines of code and you're supposed to type it in, then you're going to run out of time. So you're not going to want to do that. There is something in, I don't even know where it's stored anymore, called a locker. And I wouldn't mind if y'all stuck documents in the locker wherever it is, but if you took it at the library instead. If you can't be here that day, you can take it on the library, at the library, not on the library, at the testing center there. You don't have to take it that day. I'll open it, that day, and then as long as you get it done by the following class period, which includes, the break, but the library's not open then. Alright, so where'd that go? Anyways, I'll rearrange it so that you can find it. So I want to go to our website, not our website, the Python resource that I recommended. We're just going to look at it really briefly. Chapter 1, we're going to, slide 1, we're just going to scroll through remarkably quickly. The reserved words, the key words, are the words that make up the language. We cannot use those words for our own purpose. If we did something like raise equals 3.2 times, annual pay, we get a syntax error because raise is a reserved word. Fortunately, idle color codes things. So if you're using idle or another editor that's designed for working with Python, then you're going to be able to tell real fast that that's not going to work. And you'll just pick another word for it. A more subtle error is if you rename a function as a variable, which is really easy to do. But like if I did this, raise is equal to 10%, invalid syntax, and you go, what? Hopefully you eventually realize that that brown word, that orange word is, a reserved word. But if you do something like this, sum is equal to 3. It doesn't mind doing that, but there used to be a sum function. I've now effectively erased the sum function. What I've done is I've actually made this a reference to something else, so the sum function is no longer available. Yeah, big deal. If you quit idle and you come back to it, the sum function is there now, right? But if you're starting to type in variable names, you're creating new variables, and it shows up as any color other than black, that's a strong sign that you shouldn't be using it. Sometimes it's okay to reuse that. I love the word sum. It's easier to type than total. I wish it wasn't, a reserved keyword, but it is. So I try to avoid using it. By the end of the semester, we're going to know a goodly portion of these. There's also several that we're not going to use. Some kind of specialty stuff. Lambda. I doubt we're going to use yield. But we're going to know what global does. We're going to know what assert does. We've talked about except, and try. And then there's a finally. That'd be worth looking at for a brief moment. We know what def is. We know what for is. We've talked about break, right? Have we talked about break?
Yeah. Yes.
We haven't talked about continue yet. And I'd like to hit those topics real briefly since we're doing a review of the based on the website rather than our book. It's all right to not type this in. If you want to type it in, that's okay. Are we really on H?
Okay.
Okay, all righty. So if you have a loop, a for loop, for x in range, we're going to start at 1. We want to count up to 10, so I'm going to make that what?
11.
11, right. And I'm going to print out x. And then if I do this, if x equals 6, I really hate the number 6. We're going to print a message, breaking at 6. And some comments so we can keep track of our indentation levels. All right, so it counted up to 1 to 6 and it broke at 6. Now in this case it's stupid, right? But this could be any condition we wanted to. The user decided they wanted to stop, we couldn't open a file. Well, wait a minute. I was trying to demonstrate something and I forgot to actually put the keyword in there that I wanted to do, right? Break. Okay, now it really will break at 6, right? Okay, so it stopped at 6. What break does is it jumps to the first line after the loop. But there's another word, keyword, also having to do with loops. It does about the same thing as break, but significantly different, really. It jumps back up to the top of the loop rather than the end of the loop. And I'll show you what I mean there. I'm going to stick something before the print statement that checks to see if x is equal to 4. And if it's equal to 4, we're going to continue, which means it skips the rest of the loop. It jumps back up to the top of the loop. So, if x equals 4 colon, print parentheses, quote, continuing, or just continue, and then actually do it, unlike what I did last time. So break forces an exit from the loop. Continue forces an immediate reiteration of the loop, skipping the rest. Both of them stop anything from happening after this point, right? If you hit break, although I don't have any code here, after the end if there was any, then it would stop, right? But anyways, 1, 2, 3. We skipped 4 because before we got to the print for 4, we checked to see if it was equal to 4, and continue forced it to go back up to the top. So it skipped that statement. Totally clarify the point. I'm going to cut that print x, paste it below that end if. And so what that's going to show is that when it breaks at 6, it's not going to print out 6. Previously it was printing out 6 and then saying breaking at 6. And so that's what we got. 1, 2, 3. We skipped 4 because we did a continue before it got to the print. Then it printed. It worked its way through all of this stuff because it wasn't equal to 4 or 6, so it printed out 5. And then at the last iteration, it cruised on down here. This was true, and so it broke, meaning that it skipped that. If you litter your loop with a whole bunch of continues and a whole bunch of breaks, it makes it hard to follow. So use those judiciously. Use them sparingly. But if it seems to make sense, go for it. Well worth reading. Even though I'm skipping past it, I'd like for you to open this website. And I'm not going to make a quiz over it to prove that you read it or something. I guess I could make a Dropbox that said, upload a document when you've read it, or a quiz, box that said that you read it. you know. Well worth your reading. Well worth your reading. Or at least skimming and going, oh, that looks slightly unfamiliar. I'd like to know that. I'd like to know that. All right, so I'm going to go back to the chapter 2. Variables. We know what variables are. We know that there's effectively 2 numeric types. By the way, I saw somebody use the word type in one of their assignments. I don't remember whether it was in this class or another class. You're never going to put that in your program. You don't want it to print out that it's a float or that it's a string or whatever. Just because I use the word type, like let the user type, you know, the interest rate, doesn't mean you're going to use that keyword, right? If they're going to type something, you use input. If you're going to type something back at them, you're going to use print. This is just kind of like a diagnostic. If you're curious about the type of something, you could check, right? You know, and it would print it out. There are more sophisticated uses for it, but we're not hitting those. So what is a variable? A variable is a name that refers to a value, and it's got 4 pieces. I think I've said this before. This may be slightly different than how the book words it, but we're smarter than the book. Quote, quote, quote. Variable. It's got 4 pieces. It's got a name. It's a named place in memory. So it's got a memory address that it points to. It's got a type. And it's got a value. Now, we don't know what the memory address is. We have no idea. Unlike the C language, where you can crank out the memory address and you can do weird things with it, which makes those languages really powerful, but also incredibly fraught with error to program. So I'm going to move memory address down to 4, because in our mind, it's the least important one. We don't even have any access to it. Like that. So if we do this, A is equal to 331.2. What's the name of the variable? The name of the variable is A. What's the type of the variable? It's a floating point number, so it's a float. What's the value of the variable? Yeah, 31.2. Memory address, who knows? These are the 3 that I really want you to know. If I did ask you for the attributes of a variable, I would say something like, what are 3 attributes of a variable? And any 3 of those would work. So I could ask, you know, what are 3 attributes of a variable? In which case I want you to come up with 3, preferably the first 3. The act of giving a value is called an assignment. In this language, we do not declare our variables. We do not initialize our variables. Well, you could initialize them, yeah, but you assign a value to your variable, and it does the initialization, and it does the declaration of it all at once. So assigning does what other languages would call declaration and initialization. What is the assignment operator? What do we use? If I'm going to stick a value in a variable, bigger in life, it's at A equals. What did we use? We use the equal sign. Equal is the assignment operator. Some books call it a token. I don't know why they call that a token when greater than, less than, not equal, and all those other things are called operators. I'm going to put token in parentheses just in case this is the text that does that. Forget. You'd think that computer science, being so precise, would have a unified terminology, but it's not really that precise, right? Lots of people are inventing lots of different things and lots of different ways to look at it. Fundamental concepts stay the same through a lot of that, but just like if, I'm not going to even come up with similes. We have talked about 4 types of variables so far, ignoring exotic ones like turtle. Somebody give me a few of the types that we've seen. Already listed them up at the, pardon?
Integer.
Yep, we got integers. What's the other kind of number?
String. Float.
Yep, floats and strings. And lastly, we've done very little with them, but Booleans, which hold true or false. So I'm going to put true/false there. What are Booleans for? So you can do things like this. Error equals true, and then later on you could do if error. Take the parentheses off. Right. It's also called a flag. I'm setting a flag that I'm going to act upon later. Why would we do it that way? Because the thing that sets the error, the condition that sets the error may be, a very long expression or something that's not easily wrapped up into an if statement. If file open equals false, right? You were unable to open the file for any number of reasons. File wasn't there, disk was full, whatever. So that's a Boolean variable. Some people call it a flag. Technical name is Boolean variable. Colloquial term is flag. Assigning names, you're allowed to use one special character and digits and letters. Now names, identifiers apply both to variable names, class names, and function names. We mostly think of them as being variable names. So, letters, you could just say alphanumeric, and digits, and underscores, and there's a special rule, cannot begin with a digit. Now, honestly, people almost never run into that in the first place, right? We always type in A1 equals rather than 1A. But if you were attempting to make something that said 2017 revenue, that would not work. So identifiers apply for us right now to variables and functions. So what is a statement? You have expressions and you have statements. An expression is either a single value or a series of values chained together with operators, right? So single value or a series of values, and this makes it sound more complicated than what it is, connected by operators. Fred is an expression. 3 is an example. Pi is an expression if you've defined those. Now, if you enter an expression into Python, it doesn't complain. It'll do it, but what does it do? It doesn't do anything. What do I mean by that? Let me restart the shell. Right, 3. If you put a 3 in your program on the line all by itself, it doesn't do anything, right? If we say A is equal to 4 and then we just we do A, right, doesn't do anything. So these are just expressions. These are simple expressions, right? So these are what are known as literals, also unnamed constants. Colloquially, the numbers are known as magic numbers. They just appear in the code. You don't know what they mean. Or you do know what they mean, but if you had to change them, you'd have to go and change them everywhere in the code. This is also literal. It's a numeric literal. Same thing, unnamed constant. Pi would be a variable, also known as a constant. Hope the text calls it a constant because this language does not really call we just decided that if it's in uppercase, it means it's something that you should not change. We say it's a constant because it's in uppercase. I just mentioned that because of people who came here from Java or C rather than Python are used to being able to use constants. They use two different keywords, const or final, not this language. And then x, right, or y or z, that's also a variable. And you can chain these expressions together with symbols like addition and subtraction and, you know, that kind of stuff. These are simple expressions. We don't normally think of 3 as being an expression, but technically it is, because an expression is a single value or series of values connected by operators that evaluates. Maybe I won't even say that. It becomes a value after it's evaluated. It turns into a value when the expression is evaluated. Now, 3 already is a value, right? There's just about no evaluation that's needed done for it. But x plus 3, that's a lengthier expression, right? Pi times r star star 2 is an expression. It's a lengthier expression. All of these things are expressions, but this is what we typically think of when we think of an expression. Besides math symbols, you have logical symbols, comparison symbols. X, not x equals 3. We're checking to see if x is equal to 3. Looks like a statement, but it's really an expression that evaluates the true or false. So I'm going to call it a Boolean expression. Still just an expression. You know. And then, you know, if A plus B is greater than C. That's another Boolean expression. Ditto. What do you use Boolean expressions for? Where have we seen things like x equals 3? Kind of two different keywords use those. And we've been using one of them since day one. What have we used things like x equals 3 or if choice equals 1 or things like that for?
If statement.
Yeah, if statements. So Boolean expressions are used in if statements or while statements. I'm capitalizing if for while, even though you don't in this language, right? Operators and operands. In this statement right here, in this expression, what's the operator?
Plus.
The plus sign's the operator, which makes the x and the 3 the operands. So operators are the symbols, like plus. Operands are the data the symbols work on. If you have a complex expression, the result of one expression is used as the operand for another. So for example, if you have x plus y times z, we know by now that multiplication always happens first. So that is an operator, which makes y and z operands. And then the result of this is one of the operands for the plus operator. So plus is the operator, and x, and the result of the prior expression. Now, a statement could consist of a single expression. Usually a statement is something that can use an expression, right? Print A, if B equals C, or it's a function call, or it's a control structure, right? Like a loop statement or a range statement, things like that. So their definition of a statement was it's a unit of code that Python can execute. We've seen prints and we've seen assignments. There are other ones. When you type a statement in interactive mode, otherwise known as the shell, it executes it and displays a result if there is one. So a script usually contains a sequence of statements because writing a program with just one line of code would be kind of silly. Statements tend to execute from top down, but there are some exceptions. If you have a DEF, then the statements inside that function do not execute. They're skipped for now. If you have a loop, then it can cause a block of statements to repeat. If you have an if statement, then some statements may be ignored. And then if you have a function call, it jumps to wherever the function was or is previously defined, does those statements, and then comes back. I think we have hashed out order of operations enough. We all know that multiplication happens before addition. Are we good on that? PEMDAS, PEMDAS. Do know the specialty operators that you're not familiar with from junior high. We do know plus and minus and multiplication and division, but there's also slash slash, which is floor divide. Floor divide, and then we have modulus. So floor divide rounds down. Modulus takes the remainder. That doesn't mean you have to do the floor divide first, before. So 10 modulus 5. 5 goes into 10 two times with a remainder of. Well, it went in evenly, right? So is there a remainder when 5 goes into 10? I think I heard a no. I wish that had been more resounding. How about 11 modulus 5? Although, on the other hand, I know that some people don't want to answer every question, and so I'm cool with that too. Okay, so 11 modulus 5. 5 went into 11 two times with a remainder of 1. Yeah. String operations. Strings basically only support 2 operators. Addition, which does concatenation, and star, which does repeating. We don't usually use the star. It's the only language I've ever seen with it. But if you did this, x equals Bob, end quote, times 10, and then you print out x. The only thing I've ever used that for is like to print out a line of underscores or something like that, right? Print, I want 20 underscores. 20 underscores, right. Makes it pretty. So these are all arithmetic operators. Arithmetic, but then we have the 2 string operators. You have addition, which is concat, or concatenation, which is appending. And then you have multiplication, which is repeating. Example, 3 times Bob equals Bob, Bob, Bob. And I'm going to give an example of concatenation as well, although it's so easy. Right? Donald, in quote, plus a space inside quotes, plus Trump. We know what that's going to result in. It's going to result in Donald Trump, like that. Wave your hand if you're not comfy with the idea of what plus equals does. Plus equals is the same as, or like A plus equals 1. Come on, get back down there. Is the same as A equals A plus 1. And instead of the plus, you can do star exponent. That's kind of a weird idea, but you could use A star star equal 2, and it would square that number and store it back into the result. So there's also times equals, divided by equals, subtract equals, and even star star equals. I think I forgot an equal sign on this one. And floor division equals. It looks like I repeated one of these twice. There we go. So A star equals 10 is the same as A equals A times 10. Plus equals also works on strings. Just does a concatenation. S plus equals cool is the same thing as S equals S plus cool. So asking the user for input. We use the input function. This would be a really extraordinarily bad idea to do because we're using a keyword, we're using a function name to store the results of a function. Once you did that, the input statement would be broken from that point on. Right. Input equals, input parentheses, right? And so I have to type in something. If I type out, if I do, I can use that variable if I wanted to, but I can no longer use it as a function. X equals input, boom, like that. I've effectively erased the input function. Technically, I've just erased the reference to it, so it's no longer usable. So we may as well put a few examples of input. I don't know why I'm tabbing that far. I'm going to stop tabbing. Hopefully you weren't. Asking the user for input. Prompting is displaying a message and then asking the user for input. And you could rephrase that. Allowing the user to type in a response, right? So you could do things like this. Print parentheses quote age, question mark, and then you could let them type it in. Age equals input, parentheses, in parentheses. After we have that, we'd better turn it into a string, a number, so age is equal to float, age. That's one way of getting input. Or we could boil that down into one line. Slightly easier to type. Age is equal to float, parentheses, input, parentheses, and then our prompt. Age question mark, end quote, and then in parentheses and then in parentheses, like that. The only difference between the two things is that here the input is allowed on the same line as the text output, right? It'll say age question mark and it won't go to the next line. It'll let you type it in right after the question mark. But if you do it like this, then it prints out age, goes to the character turn, and then it lets them type it in. If you have a preference for one or the other, you know how to do it. I guess you could fake this out by putting a slash in there, right? And that would force it to go to the next line before typing it in. That would be an exact duplicate of this. If you need a whole number, and it's rare that you need a whole number, but sometimes you need to. If you need a whole number, use int instead. About the only time I've seen us need a whole number is if we're asking the user for a value to use in a range statement. The arguments of a range statement require whole numbers. So, top equals int, whatever they typed in, right? And then we could use that in a range statement, right? For x in range, starting at 1 and then going up to top plus 1. Like that, right? If we had used float there, it would kick out an error. It's kind of too bad that the range statement does not allow fractional numbers because for loops in other languages do. In those languages, you could say for x equals 0, x plus equals 0.5, and it would add 0.5 to it each time. And we don't have that option here. Not use into instead. It's funny how the fingers type something than what you type. I mean, what you say. There we go. For example, range arguments must be ints. We know what comments are. We understand that we're supposed to choose good variable names. We understand why I cheat and use single letter variable names up here to make it easy for you all to type. If you're doing something like the interest formula, I don't care if you use P and and I and stuff like that because the formula is just sitting there bigger than life in front of you. But you could have also used the whole words. You could have used principal, and interest, and years, things like that. Bad variable names. Now that looks stupid. But people can come up with, variable names that are hard to read, that aren't stupid like that, but they're just hard to read. If you overly abbreviate something, then it can be hard to read. This is demonstrating stepping through a list with a for loop. Howsoever, they haven't shown declaring the list yet. If we had a list called words, then this would take every word in turn out of that list and print it out. Now, I particularly love this syntax, but I also particularly hate it. Why do I say that? If I come down here, and let's just give a little example of that. I'm going to end quote it so I can give an example of that. Let's say we have nums equals, and then inside our list, I'm just going to type in some numbers separated by commas. 8, 6, 7, 5, 3, 0, 9. And then I could write a for loop that steps through it. For num in nums colon print parentheses num. Now every time I do this, maybe not this time because y'all are paying really close attention and I'm going to point it out, but every time I do this, somebody leaves off the S here. They put an S there. They put an S there. Anyways, right? Because if the variable names only differ by one letter, it's really easy for you to make the mistake. And I'm not just saying in a classroom environment, even when you're working on it at home. So it's really a cool way of doing it, right? Because, wow, this is a number inside my list of nums. It makes sense, but You know, similarly, you could do for name in names, right? It looks great, but I would rather do something like this. For value in nums, or for E, short for element, right? For E in nums, print E. Less chance of getting confused about what they are. E is one of those variable names that I don't mind making a single letter. Counters, why not just use single letter, right? If I'm going to use, if I'm going to make a counter that iterates 1 to 100, I could just use X, or I could use I if I'm going to use it as an index, rather than type out the whole word counter or index. It's just a personal thing. Also, when I'm stepping through a for loop, I don't mind using E for element if it's a list, or V for value. E is about my favorite, I think, for a for loop in that fashion. We've talked about two different types of for loops. We've talked about range-based for loops, and we've talked about, still haven't come up with a good name. I guess I should call it a list-based for loop. I don't recall what the textbook calls it to differentiate them. For a while, I was calling this a for-in loop, but that sounds stupid. It's a foreign loop. Well, I don't want no foreign loops. I want a good old American loop. So here's our example. For every word in the words list, for every slice in the pizza list. Well, that's not so bad. At least these are different words. Is this every digit on the phone? It can't be. What's missing from it? 2. 1 and 2. If 2 in nums, print parentheses, there is a 2. And we absolutely have not seen this syntax in this class. You may have in the prior class if you took it. And then just copy and paste that and replace it with a 3. And I better stop because I know that some people, I may have lost you or gotten syntax errors. But what this does is it checks this list for the occurrence of that number, of that element. And if it's in there, then it goes in there. We're not going to see there as a 2 because we know what are in the nums, 8675309. There's no 2's in there. However, there is a 3 in that list, and so it is going to print there's a 3. Or it could just blow up. See, I told you, whenever you mix up plurals and singulars, you goof. I did. The line is, the error is in this line. What did it need to be? Nums. Right, because nums is the name of our list. Got me. There was a 3, but there was not a 2. Just to torment y'all. So our glossary, we know what an assignment is. We know what a concatenate is. We know what a comment is. Evaluate is just to take that expression and to boil it down into a single value. 1 plus 2 evaluates to a 3. We know what floating points are. We know what integers are. We know what keywords are. Those are the reserved words of the language. A mnemonic, just a fancy word for a memory key. PEMDAS, P-E-M-D-A-S. We know what operands are. We know what operators are. We know the rules of precedence, parentheses first, exponents, multiplication, division. A statement is a section of code that represents a command or an action. We know what a string is. We know what types there are. We know what a value is. It's a result of an expression. And we know what a variable is. Conditionals. A Boolean expression is one that evaluates a true or false. Now this is supposed to be a tutorial with little windows to type in stuff. I'm not seeing the little windows. I must have some kind of pop-up blocker or ad blocker that's forbidding them. So examples of Boolean expressions. The not keyword is the only one that we haven't hit in our notes so far. So if we do this, if x is less than y, that is the same as if not x greater than or equal to y. Now that looks goofy, right? It looks like, why didn't we just make it greater than? Because if you don't change it to an equal, then you're not handling the edge case. What if x was equal to y? Would this trigger? Is 10 less than 10? Somebody tell me no, 10 is not less than 10. Thank you. All right, and now we're going to check to see if these two values will produce the same thing. Is 10 greater than, if I had left the equal, that is. Is 10 greater than 10? No, but the not would turn it into a true. These were meant to be identical statements, but they weren't. So the opposite of less than is greater than and equal, and so on, right? The opposite of greater than is less than or equal. We have three logical operators, and, or, and not. You just chain them together to make more complex expressions. If age greater than or equal to 18 and citizenship equals true, then we can vote. And means both sides have to be true. Or means if either side is true. If money is less than or equal to 0, or I'm sick, I'm not going to go out to eat. Either one of those conditions will be true, and I'll decide to stay home. And by the way, if you see this citizen equals true, I totally goofed this up in a couple of ways. One is a serious error, that would be a syntax error, and the other is just kind of a logical frippery. What is the syntax error in this in this statement? How do you compare two values for equality? Is that equal sign correct? No, it needs to be two equal signs. You can't interchange them. So or is only true if one or the other or both sides are true. Or is true if one, the other, or both sides are true. In electrical engineering, there's something called exclusive or, where if they're both true, it flips back to being false. It has to be either one side being true or the other one, but not both. We don't care. Conditional execution, also called a selection statement. These are your if statements. If x is greater than 0, do something. Since there's no else, it does nothing. Right? Just like here, we didn't have an else here. So, I guess technically we should have put an else, right? We would say something like, go out to eat. Something like that. Instead, I'm going to make one more example. If temperature greater than 212, print boiling. And I guess I could have ended this, these comments so that it would actually do something to make sure that our syntax is correct. That's an example of a singular selection statement, conditional. Or you can have if else. If age is less than 18, or, wait. Print, parentheses, too young, else, print, just right. The youth of America would hate that statement. Okay? Or we could do if, elif. If temp less than 32, or, let's not get it too complicated. Temperature is less than 32, print, boil, wait, that's freezing. Elif, temp greater than 212, print boiling. Else, print liquid. Making some assumptions like this is water and the pressure is 1 atmosphere. And that no solvent has been added to the water. Alrighty. Anyways, so we see the 3 different types of selection statements here. Here's something or nothing. Here's something or something else. And here's one of several statements. You can chain a whole bunch of those elifs together. If you're going to chain a bunch of elifs together, you should always put an else at the bottom anyways, just as a dangling, error catcher. So this text calls the else alternative execution, right? Do something or something else. And then the book calls elif a chained conditional. Not the book, this online page. Then you can have nested conditional, which is just an if inside of an if. If. I could have worded that thing about whether it was ice or not as a nested conditional. I'm not going to bother. You can imagine what it looks like. Something like this. If something else, yay, else, nay, right. And then you'd probably put some kind of third choice down there, but that's just a nested if statements. You can nest any kind of control structure and any other kind of control structure. You can put ifs inside of loops, loops inside of ifs, loops inside of loops. Why do I have the word net down there? I think I was trying to type in else and completely botched it. I don't know. Oh, nested. And then catching exceptions using try and except. There's a third part of it, which I have not demonstrated yet, called finally. Something like this. We're going to let them type in input, but if they type in bad input, we're going to kick it out. Now I'm going to fake it. I'm not going to actually let them type in anything. So the string is equal to 1. But this should have been a 1. And now we're going to convert that to an int or a float. I equals int parentheses s. That's going to fail. That's an exception. We should be putting this in a try block so that it will not halt the execution of our program. So I'm going to go back and revise it to that case. Try doing this. Except if it blows up, then we're going to print an error message. Print error defaulting to 1 or 0 or some value. And then when all that is done, go ahead and do something. Print the data is, in quote, comma, I. Oh, and I said default to 1. I didn't actually make it default to 1. I'm going to do that here after that print statement. So what does finally do? Finally executes whether the try was successful or not. Usually we don't do that because you can duplicate that work. Don't make this change. Just by doing that. Right? It does the same thing. This is the first thing that happens after the try block. But there may be special cases where you want to tack on a finally. I'm only mentioning it because this site does. I'm absolutely sure the book has not mentioned this so far. Let's try it though. What I wanted to say is error, default to 1, and then the data is 1. If I've goofed it, I blew up. Because I never set a temperature, right? I use the variable temp a million times. I probably use the variable age a million times. I'm going to scroll back up here, and above that boiling statement, I'm going to set age equals, 17. And I probably even use something called citizenship. I'm not seeing that there. And then temperature is equal to 100. If I get frustrated, I'm just going to comment the whole block of code out. Yeah. So we found an error. The except clause caught it, and then the finally clause went ahead and did something with it. You'll probably never see me use finally again in this class. We're getting close to the point where I want us to stop. Okay. If you typed in notes, we're going to upload them to Dropbox K. That is not what I wanted to be at. Oh, hush. All right, there's a Dropbox K there. And we're going to have an itty-bitty homework assignment based on the loops. So based on loop examples, from our notes, one, declare a list that contains the first 10 digits of pi. Look it up. L is equal to, 3, comma, 1, etc., etc., etc. And then 2, print out those digits with a for loop. And then 3, stretch goal. See if you can get this done. Write code that will calculate the sum. This will look remarkably the same as the summation code, except instead of for x in range, 1 to max, it'll be for x in L, except the for statement would be different. And since you're calculating it, I don't know why I said while calculation, huh? Then display the result. Makes sense, guys. Alrighty. Good resource. It puts the information far more concisely than our book, right? I mean, just in 3 short web pages, we've absorbed as much as what the book has given us, and a little bit more. Alrighty. We can hang out for a few minutes after this. If you need to ask questions over homework, I've been getting text messages. That's totally cool.